Welcome back for our third lesson of this unit, discussing properties of parallelograms. Properties of parallelograms. There's a little assumption here that we know what parallelograms are, which may be a bold assumption, but basically parallelograms are quadrilaterals whose sides, opposite sides, are parallel to one another. So we're going to use the properties of parallel lines, diagonals within parallelograms, and also looking at triangles to investigate properties about parallelograms. This is going to be sort of an interesting lesson where we're going to do kind of the Unit 4 geometry as sort of a background to doing the Unit 6 geometry. And so this should be a good thing. Here are these fun facts about parallelograms. For these facts, obviously write them down. These are the theorems. We'll talk through why the theorems are true. I'll prove each one of these. But then we'll also do some examples where we are going to use the fact that, first of all, the opposite sides of a parallelogram are congruent. We're going to use the fact that the consecutive angles of a parallelogram are supplementary. We're going to discuss and apply the fact that the opposite angles in a parallelogram are congruent, and then also that the diagonals in a parallelogram bisect each other. It does not say that the diagonals are congruent, but it does say that they bisect each other. So we have to understand what bisect means, and we have to know what diagonals are. And we need to learn maybe what consecutive angles are. We can guess and use our intuition for opposite sides and opposite angles. But obviously, if you need any clarification, then stay tuned for that awesomeness. And so exploring our parallelogram, obviously pause the video as needed if you need to write that other stuff down. We know that in this parallelogram, we have done a series of proofs with these parallelograms. Typically, the way that we are given the information is that we have a pair of parallel sides. And then either we have a pair of parallel sides or a pair of congruent angles or something else. And we basically prove that these two triangles are congruent. And so we've done that a handful of times, probably 6 or 8 times in the last semester. And so I want to make sure that we draw attention to that previous exploration that we've done, that we've seen, that we've explored, and that hopefully we've been successful with. But when we have parallelograms drawn, and if we draw a diagonal in, then we know that the alternate interior angles are congruent because these lines are parallel. These alternate interior angles are congruent because these lines are parallel. We know that this segment's congruent to itself by the reflexive property, and so by angle side angle, we can say that these two triangles are congruent. There's lots of different ways that we can explore this, but basically, if we have a pair of congruent triangles, and also regardless of where I draw the diagonal, I can draw a diagonal BD or diagonal AC, and the same thing would be true if this is a parallelogram. And so to show that the opposite sides, theorem 6-7, that the opposite sides are congruent, that AB and CD are congruent, that BC and AD are congruent, we're going to show that these triangles are congruent by, again, angle, side angle. All right? So showing that those triangles are congruent by angle, side angle is helpful because then once we have shown that angles, side angles congruent, we know that by CPCTC, or the definition of congruent triangles, we know that AB is going to be congruent to CD. We know that BC is going to be congruent to DA by the definition of congruent triangles. So again, our goal there is to show that the triangles are congruent so that we can show that their corresponding parts are congruent, the opposite sides of these parallelograms. To prove theorem 6-8, we're going to do the same work, all right? Showing that we have parallel sides, but then we're going to use this same side interior angles postulate to say, hey, these corresponding angles are supplementary. Let's talk about consecutive angles. Consecutive angles, again, if these are opposite angles, then these are consecutive angles. So this is angle 1, then angle 2, then angle 3, then angle 4. If we go around, clockwise or counterclockwise, I don't care which direction you go, then we would say, hey, given parallel lines and this transversal, these same side interior angles are going to be supplementary. All right? So consecutive angles are just same side interior angles. We're just saying they're consecutive in that if we go in order, like this one and then that one, and then this one and then that one, then we can show that all pairs of consecutive angles are supplementary to each other, right? If I've got these parallel sides and then these same side interior angles, we know that they are going to be supplementary by the same side interior angles postulate. So all 4 pairs of consecutive angles are supplementary by the corresponding angles postulate. It's pretty straightforward as far as the proof is concerned, but basically we want to make sure that we know that we're talking about supplementary here. The sum is 180 instead of congruent where the angle measures are the same. So keep that in mind. So let's apply theorem 6-7 here. Let's go ahead and show that if we know that the opposite sides are congruent, then all that we need to do is solve for the variable and then substitute the value to find the length of the segment. So if we know that this is a parallelogram, PQRS, then that means that the opposite sides are congruent. If the opposite sides are congruent, then that means that their lengths are equal, which means that I can substitute in the expressions representing the length of segment QR and the length of segment PS to create this equation. I can subtract 2x and I can add 15 to solve for the variable. Once I know the value of the variable, then I can substitute that value in either here or there or both to find the lengths of the segments. All right, since QR is equal to, the length of QR is equal to the length of PS, then I can say that they have the same length. Real quick note, make a note of this in the slide here, or in your notes. The thing that I want you to do is make this statement that if you want to make sure that you did this right, plug this number into both places, and then you should get the same answer, regardless of if you use this one or that one. But if you use both, that confirms that you're getting the same answer both ways. That's a good way to check your work to make sure that you did your Algebra 1 correctly. Hopefully you're doing the substitution correctly. This is just arithmetic, right? Plugging in the numbers. This is solving, and so sometimes we make mistakes there. We sometimes make mistakes here, but if you're using your calculator, you shouldn't. All right. If we know that the consecutive angles of a parallelogram are supplementary, then we can find the measure of angle S, knowing that the measure of angle R and the measure of angle S are going to add up to 180. The measure of angle R and the measure of angle S, they should be adding to 180 because the angles are supplementary. So my equation is 112 plus the measure of angle S is equal to 180. I'm going to subtract 112 from both sides to get that the measure of angle S is 68 degrees. Find the value for x and of y. Now this is really interesting because when we're using these consecutive angles, we might be thinking here, well, 7x and y adds up to 180, and that's not helpful. Opposite angles we know are congruent. Y is equal to 8x. Okay, that's not helpful. But what is helpful is using this pair of consecutive angles to say that 7x and 8x add up to 180 degrees. Once you solve that equation and you find out the value of x, then you can use that to find the value of y here or there. I want for you to finish. You finish 2b. Pause the video if needed to write all that down and to do that work. So solve for x and then use that to solve for y. These are a little more precarious situations because if you have to use your answer from x to get your answer for y, your answer for x better be correct, right? If it's not right, then now you've missed two variables. So you want to do, obviously, a good job on the Algebra 1. If you are struggling with the Algebra 1, you don't have to go talk to your Algebra 1 teacher. You can, you're welcome to. They will support you. But come visit me in seminar and we can happily chat about your Algebra 1 skills. All right, Theorem 6.9. The opposite angles in a parallelogram are congruent. Again, if we draw on the diagonal, we use the alternate interior angles and the reflexive side, we have side-angle congruence, and then by CP/CTC, these opposite angles are congruent to each other. If these angles are congruent, then we know that their measures are equal. So the angles are congruent, that means that their measures are equal. We can substitute the expressions representing the measures of those angles, and then we can do our Algebra 1. Subtract 3y, subtract 4, and then divide by 3. All right, if we subtract 3y from both sides, and then subtract 4 from both sides, we then have the y's all on one side, the constants on the other, divide by the coefficient, and we find the value of the variable. If you want to see if this is correct, you can check your work by substituting y in here, substituting y in there. You should get the same number. You should get 70 degrees for both. Did you get 70 degrees for both? If you did, then yes, you've shown that their measures are equal. They're the same number, and therefore those angles are congruent. That's a good check. All right, the diagonals bisect each other. So I didn't prove this one in our conversation, but we could prove this one hopefully pretty easily. We would know that these alternate interior angles are congruent. We would know that these alternate interior angles are congruent by the alternate interior angles theorem. And we know that the opposite sides are congruent by Theorem 6.7. So we have angle side angle that these two triangles are congruent. If these two triangles are congruent, then that means that this side and this segment, so this part, AE and CE are congruent by CP/CTC, and then this thing and that thing are congruent by CP/CTC. And so if the parts are congruent, then that means that those segments bisected each other. And so Theorem 610 states that the diagonals in a parallelogram bisect each other. All right, so when you're asked to prove this, I just saw the proof, right? We just did it out loud, we didn't write it down. So this one's a little bit different because this one says to create and solve a system of equations to solve for x and to solve for y in this situation. So I don't know why it says in. Solve for x and y. And so what we're going to do is we are going to create that equation. We know that the diagonals bisect each other. So I know that the length of DE is equal to the length of BE, which means that y is equal to x plus 1. I also know that the length of segment AE is equal to the length of segment CE because those segments bisect each other. And so I know that 3y minus 7 is equal to 2x's. All right, well in both of these I've got two variables. So I don't know, I can't get x by itself and then all of a sudden know what it is. If you subtract 1, you get y minus 1 equals x. It's not a number, it's an expression. And so here we get to do, and this is a big deal, system of equations. All right, this is chapter 7 of Algebra 1, all right, which you did last school year. And we're going to use that to help you do this. We're going to use what's called substitution, all right? So if y is equal to x plus 1, then I can substitute x plus 1 in place of y in this other equation. So I get 3y's minus 7 is equal to 2x. But in place of the y, I'm going to write what y equals, all right? So this is what you did in Algebra 1, Unit 7. Can you now solve this equation recognizing that you have now one variable, not two variables? You don't have x's and y's anymore. You just have an equation with x's. And we should be able to do our Algebra 1 in order to solve this equation. So I'm going to subtract 2 x's. I'm going to add 4 to find out that x is equal to 4. I want to make sure it's showing up on the screen. It is, good. Now that we know what x is, we can substitute that back in here to say that y is equal to x plus 1, and so y is equal to 5. We know what x is, we know what y is. So we can find the length for these segments should we want to, but really the goal here was just to solve for the variables. Please let me know if you have questions on that Algebra 1. If you do, first thing you should do is watch that 45 seconds or minute and a half, whatever that was, re-watch that, and then see me with questions on how to solve a system of equations. Hopefully, after exploring this lesson, you can recognize that the opposite sides in a parallelogram are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals in a parallelogram bisect each other.